हेलो फ्रेंड्स, आज हम पढ़ेंगे मैक्सवेल्स थर्मोडायनेमिक रिलेशंस। मैथमेटिकल फॉर्म फर्स्ट लॉ और सेकंड लॉ की यूज करके मैक्सवेल ने इन फोर रिलेशंस को स्टेट वेरिएबल्स या थर्मोडायनेमिक वेरिएबल यूज करके फाइंड आउट किया। इन दिस रिलेशन एनी ऑफ द two variables out of four are kept constant, and then each relation is derived on the basis of one of the four thermodynamic potentials. We know that thermodynamic potentials are internal energy, Helmholtz free energy, enthalpy, Gibbs free energy. And since all these differential form are exact, therefore Maxwell relations we use the following identity. If dx that is equal to function of x and y, then it is perfect differential when it is perfect differential then del over del x, del y, keeping x constant and whole y constant because we are taking this with respect to x, and this must be equal to del over del y, del x of del x, keeping y constant and whole term keeping x constant. If we have any perfect differential, then this identity must be satisfied. Since these potentials are the state functions, they depends only on the initial state and final state in any process. Therefore, these are also the perfect differential. So, during the derivation of the Maxwell equation, we will use this identity. Okay. So, firstly, we see the first thermodynamic equation. First, Maxwell equation. Maxwell relation equation. So from the first law of thermodynamics, we know that dq is equal to du plus pdv, or tds is equal to du plus pdv, or du is equal to tds minus pdv. Means that u is function of s and v. Okay, then we can write this as taking its partial derivative. Then we can write del u del s keeping volume constant, that is equal to T, and del u taking its derivative with respect to V, keeping S constant, we get minus P. From this we can see that if we are taking S constant, then ds term 0, then du over dv, that is keeping S constant, must be equal to P. That's why we are getting this with negative sign minus P. और हमने पहले भी बात कही कि du जो है वो परफेक्ट डिफरेंशियल है, तो सिंस du is perfect differential, so we can write this as del over del s of del u del v, keeping s constant, and with respect to s we keep v constant. This must be equal to del over del v del u over del s, keeping v constant, and for all this s constant. And from these equations, these two equations, we can see that del u over del v, keeping s constant, is equal to del t over del s. And del u over del v, this term keeping s constant, must be equal to p minus of p and whole volume constant. Del over del v, del over del v of del u over del s, keeping v constant, is equal to t. Put here t and keeping entropy constant. So therefore we are getting del t over del v, keeping s constant, is equal to minus del p over del s at constant V. This is our first Maxwell relation. Similarly, we can find out the second Maxwell relation. For second Maxwell relation, we know that second Maxwell relation. We know that this F is equal to U minus ds. Then dF is equal to du minus tds minus s dt. Du minus tds from second law of thermodynamics and first law of thermodynamics. What we get? Du minus tds is equal to minus pdv, and this is equal to minus s dt. This implies that f is depending upon v and t. So partial derivative of f del f del v with this b, keeping t constant, it is equal to minus p, and del f del t, this del t, keeping v constant, that is equal to minus of s. Because if we taking this with respect to t, partial derivative of f with respect to t, then keeping this volume term constant, and dv change in volume will be 0, so pdv will be 0. So we are having del f del t is equal to minus of s. And also df is perfect differential. To we use that identity, so must del over del v, del f over del t at constant volume, and whole is at constant temperature. That must be equal to del over del t of del f del v at constant t, and totally volume is constant. Then this is equal to del over del v, del f del t at constant volume, that is equal to s with negative sign. This is equal to del over del t, del f over del v. This is equal to minus of p. Minus minus cancel out. So this implies that we are getting del s over del v, that is equal to del p over del t. Obviously, this is at constant t, and this is at constant v. So this is our second Maxwell relation. Like this, for third Maxwell relation, and we use enthalpy. Enthalpy H is equal to U plus PV, and dH is equal to du plus pdv plus vdp, and du plus pdv is tds plus vdp. dH is equal to tds plus vdp. This means that H is function of S and P. So we'll take its partial derivative, then del H del S, this term, keeping P constant. Then what we will get? This is equal to T, and del H del P. Now we'll keep S constant. Then we get volume V. Again, since H is the perfect differential, so therefore we will write this dH is perfect differential. It is perfect differential. Therefore, what will we write? Del over del P into del H del S at constant P, whole is at constant S, that is equal to del over del S del H del P at constant S, and this all is at constant P. On comparing these equations, this and this, what we'll get? Del over del P, it is equal to del H del S, that at constant pressure this is equal to T, and that is equal to del V over del S at constant P. This is our third Maxwell relation. Now we will find out fourth Maxwell's relation. fourth Maxwell relation is, we know that Maxwell thermodynamic fourth equation we can find out with that gives free energy, that is equal to, we can write as U plus PV minus TS, or dG is equal to du plus pdv plus vdp minus tds minus sdt. Du plus pdv, that is equal to tds plus vdp minus tds minus sdt. TDS cancel. dg is equal to vdp minus sdt, means g is function of p and t. Okay, then we take the partial differentiation of g with respect to p and t, then what will we get? dg dp, keeping t constant, that is equal to v, and del g del t, keeping p constant, what we get? Minus of s. Again, since dg is perfect differential, dg is perfect differential, so we can write the identity as del over del t del g del p at constant t, and this is at constant p, that must be equal to del over del p del g del t at constant pressure, and this whole is at constant t. Comparing this, what we'll get? Del over del t del g over del p at constant t is, we get v from here, and this is at constant pressure, and this is equal to minus del s over del p at constant temperature. This one, comparing this, put s here, we get minus. This is our fourth Maxwell relation. Now there is a trick to remember all these relations. What is this trick? Again, in the last lecture I have told that we'll learn this abbreviation. Good professors have studied under very fine teachers, or very fine टीचर्स. तो एक हम बॉक्स बनाएंगे यहाँ पे अगेन, और यहाँ से शुरू करेंगे. गुड प्रोफेसर्स हैव स्टडीड अंडर वेरी फाइन टीचर्स. अब इसमें हम क्या करेंगे कि हम जो है इस आइडेंटिटी को करने के लिए हम इस तरह से प्रोसीड करेंगे, टी से बी की तरफ जाएंगे. तो फर्स्ट रिलेशन लिख लेते हैं, फर्स्ट मैक्सवेल रिलेशन. तो हमने याद रखना है कि हम एरो लगाएंगे टी से बी की तरफ, ठीक है, और इसको लिखेंगे डेल टी डेल वी, और टी के जो डायगोनल होगा उसको देखेंगे, डायगोनल एस है तो उसको एस को कांस्टेंट कर देंगे, दैट इज इक्वल टू. अब सिमिलरली यहाँ पे भी ऐसे ही प्रोसीड करेंगे, तो क्या आ जाएगा ये डेल पी डेल एस, और पी के जो बिल्कुल पैरेलल है वो क्या आएगा, कांस्टेंट बी. लेकिन अब यहाँ पे जब P और S इकट्ठे आएंगे, वहां पे हम जब साइमल्टेनियसली आएंगे P और S, तो हम यूज करेंगे नेगेटिव साइन का. तो यहाँ पे क्या आ गया, ये माइनस ऑफ डेल P ओवर डेल S. दिस इज अवर फर्स्ट रिलेशन. सेकेंड रिलेशन का यूज करने के लिए हम क्या करेंगे, सेकेंड थर्मोडायनेमिक इक्वेशन निकालने के लिए हम क्या करेंगे, हम यहाँ से P से T की तरफ जाएंगे और S से P की तरफ जाएंगे. तो इस सेकेंड रिलेशन क्या आ गई, डेल P del T, और P के बिल्कुल पैरेलल में क्या है, वॉल्यूम, उसको कांस्टेंट रख देंगे, दैट इज इक्वल टू, यहाँ पे क्या आ गया, del S del V, और S के जो पैरेलल है T, इसको कांस्टेंट रख देंगे। तो ये हमारे पास आ गई सेकेंड रिलेशन। क्योंकि यहाँ पे del P और del S अलग अलग साइड हैं दोनों, तो साइन लेने की जरूरत नहीं है नेगेटिव साइन। तो ये हमारे पास आ गई सेकेंड रिलेशन। अब थर्ड रिलेशन के लिए हम क्या करेंगे, अप और डाउन, पहले हम इस तरह से डाउन गए, अब हम अप जाएंगे P से T की तरफ और S से P की तरफ। तो इसको कैसे लिखेंगे, ये आ जाएगी del V del T, और V के कॉरस्पॉन्डिंग है T, P कांस्टेंट, दैट इज इक्वल टू del S del P, और S के कॉरस्पॉन्डिंग है T, और S और P इकट्ठे आ गए तो माइनस साइन। ये हमारे पास थर्ड रिलेशन आ गई, जो कि है फोर्थ मैक्सवेल इक्वेशन। फोर्थ मैक्सवेल इक्वेशन। अब जो हमारे पास फोर्थ नंबर की जो इक्वेशन है वो थर्ड मैक्सवेल इक्वेशन है, उसको हम फाइंड आउट करने के लिए यहाँ पे रिवर्स करेंगे। पहले हम P से T की तरफ गए थे, अब हम T से P की तरफ जाएंगे और V से S की तरफ जाएंगे। तो ये आ गया del T del P, keeping S constant, that is equal to del V del S, and corresponding to V there is P, keeping P constant. Again here both del P and del S are involving, so minus sign both side will be cancel out, so this is the positive, and or we can take only minus sign when this del S and del P occur simultaneously, for example in first relation, and similarly in fourth Maxwell equation. So these are the four Maxwell relation, and this is the easy trick to learn them. Hope you understand the lecture. Thank you.